Today we're going to be talking about the Doppler effect with regards to light. So the Doppler effect is the same one that we talked about with sound, and it's where there's an apparent change of an object's frequency and wavelength, so it's regarding the wave, based on the perspective of the observer. So it's either getting shorter as a wavelength or longer as a wavelength. The actual wave does not travel faster or slower. The speed is exactly the same, but what is changing is how long the waves are and how frequent you see them. Okay, this can be applied to any wave, sound, or light. It's just a lot easier to actually imagine when you're talking about light because light is a transverse wave, so it's like this. Okay, so Doppler effect. It is used to determine if an object is moving away or towards Earth. So if we notice that there is a shift of light towards a blue, making it a blue shift. So if you think about Roy G. Biv, and then I'll just go V. Okay, what happens is that if we have a line, let's say it's going to be like this. Okay, so this is its normal look. Okay, if I looked at this element or whatever, its normal line spectrum would have these two yellow lines. Okay, if I then looked at it and what happened is it's shifted towards the blue. So maybe instead of seeing that, we see a line like this. So notice it's the same distance apart, but it's shifted more towards the blue side, more towards the blue, meaning it's not necessarily blue, but it's shifted towards the blue. That means that that object is moving towards us, okay? If we notice that it is a red shift, meaning, so I guess I'll delete this part. Okay, so let's pretend this was it before. And now it's shifting more towards the red. So we've got one, let's say here, and maybe an orange. Okay, it's shifting more towards the red. That would mean that that thing is going away from us, okay? You do have to know whether a blue or red shift is coming towards you or away from you. How I remember it is that a red shift, you see brake lights, I always think of a car. So you see brake lights, they are going away from you. If you see blue, they are coming at you like headlights, okay? So blue are like headlights that are coming at you. Red are brake lights that are going away from you, okay? So if it's a red shift, meaning it's shifting more towards the red or the long wavelengths, okay, so these are the longer wavelengths, then it is going to be going away from you. If it is coming towards you, the wavelengths are getting shorter, they're coming more condensed, more frequent. That is going to be more of a blue or violet shift. All right, so what we notice though is how it applies to us is we notice that actually everything or most everything has red shifts. And what that means is that when we look at the stars and galaxies, we notice that there's a red shift for them, which means that they are leaving us, okay? Meaning they are going away from us. And that phenomenon helps explains the Big Bang Theory and that we are an expanding universe as opposed to one that is either standing still or coming or condensing. Okay, so the red shift proves that we are an expanding universe. All right, so what would an observer observe? Where would they observe a red shift? And try to ignore the fact that they're outlined in red and blue. So if you look at this, what do you notice? If this is our start right here, okay, what do we notice is happening to that guy? Well, we notice that the waves are getting longer. And what color is that associated with it? That is associated with red. If we look at the girl, we notice that the waves are extremely short. They're getting shorter. So that means that it would be going towards us. So this would be a blue shift, like those blue headlights coming at us, right? Okay, so if the waves are getting closer and it's more scrunched up, then that is a blue shift. If it is being spread out, that is a red shift and going away from us. Okay, so once again, here's another example of this blue and red shift as far as what we would actually observe on Earth, okay, looking at its line spectrum. So this is a stationary galaxy. So this is actually what we should see. Let's say we see this spectrum. What we notice is that if it shifts towards the red, right? So it moves kind of towards that right part, so the red coloring. So it's not red, it's just shifting towards that red from what it normally is. That means it's going away from us. Look at what happened also to your wavelength. It got longer, just like red light has a longer wavelength than the violet light. So this would be a receding, meaning a going away from galaxy. This one, on the other hand, notice that this guy shifted towards the left, more towards that blue color right over here. So because it shifted more towards the blue color, its wavelength is more condensed. Okay, it's a shorter wavelength, which means that it is going towards that purple or blue light color, which has a very high frequency, and so that's why it would be approaching us. Okay, this is just another line spectrum, just with more. So a laboratory spectrum means what you should see if it's not moving at all. So if we have this, okay, then try to figure out what's happening with this one. Well, we notice that it's going more towards the red side, so it would be a red shift, which means it's going away from us. If we notice that this shift goes towards the blue side, then we know it's going towards us and it's approaching us. Okay, so notice that it's the same lines, they're the same distance from each other, but what happens is it goes more towards either the red colors or the blue colors. It doesn't necessarily mean that they are red or blue, it just shifts in those directions on that Roy G. Biv spectrum. All right, so once again, let's try to explain this chart. So what we notice as far as the color, frequency, and wavelength, once again, they really won't be red or blue, but it just kind of helps to really emphasize that red or blue shift. So if this is normal, what happens when you go down and it's moving away from you, your color becomes more red. And it doesn't become more reddish color, it just shifts once again towards that Roy part of the color spectrum. What also happens is your frequency, so I'm going to do V, is less. So you become less frequent, and your wavelength is longer. Okay, so notice that's the translation. Then when we go towards this one, what we notice is that it is more blue, so it's more of a blue color, more towards that blue coloring on the Roy G. Biv. The frequency is more, and your wavelength is shorter. All right, hopefully you have a basic understanding of the Doppler shifts as a part of light, all right, and have a great day.